Hello,
Hello, good evening.
good evening Diksha Didi. So today we are going to continue with the bitwise XOR operator example that we were seeing in the last class. So let's just start.
Okay.
Alright. So the bitwise XOR operator is the most useful operator from a technical interview perspective. So it is used in many problems. A simple example could be given a set of numbers where all elements occur an even number of times except one number. Find the odd occurring number. So this problem can be efficiently solved by doing XOR to all numbers. So using the XOR operator, we can solve this problem where if we are given this set of items, or you can say an array of items, then we have to find the one element which is repeating odd number of times. So like 12 is repeating even number of times, 14 is repeating 4 times, that means it is repeating even number of times, but 90 is only repeating one time, that is it is repeating one like odd number of times. So 90 is the number we are trying to find using this method find odd. Alright, so over here we have int array in which we have all those elements 12, 12, 14, 90, 14, 14, 14. Then we have n, that is size of array divided by size of array 0. So we are basically just taking out the length, the number of items that are there in the array. Size of array is like is we have 1 2 3 4 5 6 7 7 into 4, 28. Size of array is 28, meaning it is occupying 28 bytes, but we are going to divide that by 4, so we will get 7, right? So we will get 7, that there are 7 elements in this array. Next we are printing the odd occurring element is find odd, and then we are passing it the array and n, right? So now find odd will return us a value that is going to get printed. The find out will return us what value? The number which is being repeated odd number of times. So we have result variable, we are creating an integer result variable whose value is 0, and then we are also defining an I variable. Then we are saying for I equals to 0, I less than n, like we are looping on the array's length, right? So we are looping the number of times, if the length is 7, so we are looping 7 number of times, right? And then we are incrementing I. So we have already seen for loops where this is the structure and all, right? So this is a basic for loop through which we are going to loop on our array. In this we are what we are doing, we are saying result xor equals to, so it will do the xor with the previous so over here what we are doing, we are doing the xor of result and the current array's element, and then the value that is the new value is being saved in result. Alright, so over here first results value is 0, so xor equals to array I is 12. So we saw 12 above, that 12 is your, just a second, over here, yeah, 1100. So 12 is 1100, right? So and we have 0 as 0000, 12 is 1100. Now we are doing the XOR. So 00 will give us 0, 00 will give us 0, 01 will give us 1, and 01 will give us 1. So results value will be 12. Next or you can 12, that is equals to 1100. Next what we are doing, next element is also 12, so result xor equals to 12, right? So what we'll have, we are saying 11, we have already 1100 in result, and 12 again is 1100. So now 00 will give us 0, 00 will give us 0, 11 will give us 1, as it is xor, and like bits will give us 0, and unlike bits will give us 1, and 1 will give us 0. So all of these are like bits, right? So in the end, in result we will have 0. Next what we have, we have 14. So 14 basically what it is, so 13 over here, we have 13 over here, right? So 13 is 1101, Alright, so let's just see 14 binary representation. So it's 1110. Alright, so 14 is 1110. So now we have 1110, and we are doing its XOR with 0000. So doing it with 0000, we'll get 111110 only. So now results value is 14. Next, what we are doing its XOR with 90. So we'll add 4 zeros in front of it, so because 90 is a big number, and it has a 8-bit representation. So it's 1011010. It's 1011010. And in the start we'll have 0. So this is 8 bits, this is 8 bits. Now let's just do the XOR, 14 and 90's XOR. So what we'll have, we'll just start from the start over here from the first bit. So 00 will give us 0, 01 will give us 1, 00 will give us 0, 01 will give us 1, 11 will give us 0, 10 will give us 1, 11 will give us 0, and 00 will give us 0. So in the end, after doing XOR of 90 and 14, we get 0101 0100. And if we check this decimal, so what we'll get 84. So this is 84, right? Next, what we are going to do, we are going to do its XOR with 14, right? So 14 was this over here, so 00001110, right? This is 14. So now if we check the result, 00 will give us 0, 10 will give us 1, 00 will give us 0, 10 will give us 1, 01 will give us 1, 11 will give us 0, 01 will give us 1, and 00 will give us 0. So we get 01011010. And over here we had 01011010. So this was 90 over here, this was 14 over here, this is 84, this is 14, and now we get again 01011010, that is 90. So this over here, after doing XOR of 84 with 14, we again get 90. Now when we do XOR of it with 14, that we did over here, we'll get 84. And then when we do XOR of 84 with 14, we'll further get 90. So in the end, results value is 90, and 90 is getting returned. That will get printed over here. The odd occurring element is 90. So is this clear? The example, very cool example this is.
It's clear.
Alright, great. So next, we are on the bitwise operators should not be used in a place of logical operators. So they can be used, but they should not be. So we are going to see why. So the result of logical operators, double and, double, like when we give two and symbols, it is a logical and. When we give two pipes, that is logical or, and the exclamation mark is logical not, is either 0 or 1. So these logical operators will give you either 0 or 1. But bitwise operators return an integer value. Sorry about that. So bitwise operators will give you an integer value. So also the logical operators consider any non-zero operand as 1. So your logical operator will consider any non-zero operand as 1. For example, consider the following program. The results of and are different for the same operands. So when you use single and, that's a binary bitwise operator. When you use double and, it is a logical operator. So mostly it's just telling us that people get confused and by mistake use the single and they get unexpected results. So we should not use single and in the place of double and, right? That's what we will get to know from this example. So over here we have x equals to 2, that is 0010, and then we have x equals to 5, that is 0101, right? When we say x and y, let's just check the result. X equals to 2 is 0010, x equals to 5 is 0101, right? And then when we do and of it, then let's just start from the start. 00 is 0, 1 is 0, sorry, 1 0 is 0 and 0 1 is 0. So in the end what we get 0 overall. Now when we are getting 0, over here the value that will be put will be 0. After the question mark, after the question mark, if this value is truthy, then the code after the question mark will be executed. If this value is falsy, then the code after the colon will get executed. As 0 is representing a false value, this part cout false will get executed. Next what we have x and y. So we are checking if both the values are truthy. So 2 is truthy and 5 is truthy. So over here we'll get 1. Now 1 is a representation of true, and when the value over here is truthy, the code after the question mark is getting executed. So over here above we were getting false was getting executed, and over here in this example true will get executed. So is this clear?
That's clear.
Alright, great. So the left shift and right shift operators are equivalent to multiplication and division by 2 respectively. So now one interesting thing is when you left shift on a number or when you right shift a number, that is equivalent to multiplication by 2 and division by 2, but the division is flow division. So we are going to see what happens. So over here we are left shifting this x equals to 19 by 1. So when we left shift 19 by 1 bit, then what will happen, it's equivalent to multiplication by 2. So without looking at the result, if we say 19 into 2, we get 38. So 38 will be the result of x or by left shifting x by 1, right? And if we right shift x by 1, then what will happen, so as we have 19 in x, right? So when we right shift it, 19 divided by 2, that will be 9.5, and as it is floor division, it will just cut off the decimal and take the floor value, so we'll get 9. So over here we were getting 38 as it was multiplication by 2. Over here we are getting 9 as it is floor division by 2. Alright, so we are getting 38 and 9. Alright, so the AND operator can be used to quickly check if a number is odd or even. So we can quickly check if a number is odd or even. The value of the expression x and 1. So if you have any number x and you say and 1, would be non-zero only if x is odd. So the value of this expression will be non-zero if the expression is odd, otherwise the value would be 0, right? So x and 1 will return 0 if the value is even, and it will be non-zero only if the value is odd. So we over here we have x19. When we say x and 1, we know instead of just doing the AND operation and checking if it is an odd or even number, what we do directly know, x and 1, if this is an odd number, then if it's an odd number, then we'll get a non-zero value. If it's an even number, we will be returned a 0 value, right? So 19 is an odd number, so 19 and 1 will return you a non-zero value. A non-zero value represents truthy, and the code after the question mark will get executed, that is odd. So cout odd, so odd will be printed on the screen. If we had 18 over here, then 18 and 1, what that will give us, it will give us a 0 value, as they have told us that if it's an even number and when we do it's AND with 1, it will always give us 0, and when we are getting 0, the code after the colon is getting executed, and when the code after the colon is executed, we are getting printed even. So we'll get even over here. So we are getting even. Alright, so next example, this operator, I just forgot what it was. Basically this is a binary operator that will inverse all of your bits, right? So the result of this operator should be used. The this operator should be used carefully. So result of this operator on a small number can be a big number if the result is stored in an unsigned variable. So now this is a very important concept that we are going to see, and the result may be negative number if the result is stored in a signed variable, assuming that the negative number are stored in 2's complements form where the leftmost bit is the sign bit. So now every number mostly you save in 2's complement form, right? So what this is used for, this operator over here that inverse basically reverses your bits. What in a signed number we have a equals to 1, so when we reverse the bits, the first bit it's saved as 2's complement, so the first bit is taken as signed bit, and basically when we reverse the bit we'll get -2, right? But for example, there is no signed bit, we have an unsigned variable, right, whose value is 1. So let's take this way. So we have mostly it's saved in 8 bits, or integer is saved, your integer is saved in 4 bytes, right? So we have, for example, 0 0 0 0, so 4 bytes is 4 into a 32. So 4 1 2 3 4 5 6 7 8 8, then you have 16 24 32, right? And this is 1. So this is the representation of 1, right? Now when this is a signed number, then what will happen, this will give you a signed result, right? So this will change the sign of the number and give you the result. So by using this operator over here on a, right, that is a signed, that is saved as a signed number, you will get -2. But when using the same operator on an unsigned number, then what will happen, all the zeros will become 1 and the last one will become 0. So what will happen, just a second, I'll just show you what will be the result. 8 and then 16 24 32, and this will be 0. This will be a large number that will get executed. Now if we check, we are getting result 4294967294, so a very big number, right? But if we check its decimal also, I believe we are going to get the same number. So let's just check, enter the binary number, convert. So we're getting 4294967294, 4294967294. So we are getting such a big number, right? So when it's a signed number, we are getting -2, but when it's a unsigned number, right, then what we are getting such a big number. So when using mostly this operator is used to change the sign of your number, and it's not usually used with the unsigned unsigned numbers, right? But when used with unsigned numbers, it will give you such a big result. Now I hope all of these examples were clear.
Good of you.
Alright, great. So next, what we have in operators, we have your assignment operators in C++, right? We have seen the bitwise operators. Now we are on assignment operators. So over here, this is the operators table in C++. So assignment operators are used to assigning values to a variable. The left side operand of the assignment operator is a variable, and the right side operand of the assignment operator is a value. So the value on the right side must be of the same data type of the variable on the left side, otherwise the compiler will raise an error. So if on the left side you say variable int a, then you'll have to give it the value integer only. So equals to, you'll have to say 0 or 1. You can't say int a equals to hello, that will be wrong. As what will happen, your int a is int a can only store an integer value, and if you give it a string value, that will actually lead to an error, as it is meant for saving integer data types. So different types of assignment operators are shown below. First is the most common equals to operator. So this is the simplest assignment operator. The operator is used to assign the value on the right to the variable on the left. So for example, a, that is equals to 10. b that is equals to 20, and ch that is equals to y. Ch over here is basically a variable name, right? But over here we are interpreting that these variables are already declared above, right? Then only we can do this, right? If these are not declared and we are directly trying to create variables without giving the data type, that will lead to an error. Next we have the plus equals to operator. So this operator is combination of plus and equals to operators. This operator first adds the current value of the variable on the left to the value of the right, and then assigns the result to the variable on the left. So what is happening over here when we say a plus equals to b, whatever is the existing value of a, that value the b's value will be added to that value, right? And the new value will be the result that will be saved in a. So for example, a's value, original value is 5, b's value is 3. So what will happen, 5 plus 3, that is 8, and that 8 result will be saved in a. So this can also be written as a equals to a plus b, right? That is the same thing. So if initially value stored in a is 5, then a plus equals to 6 is equals to 11. Alright. Similarly, we have the minus equals to operator. This operator is combination of minus and equals operators. This operator first subtracts the current value of the variable on the left from the value on the right, and then assigns the result to the variable on the left. So very similar to the plus equals to operator. The difference is that the plus equals to operator was adding and the minus equals to operator is subtracting. So for example, a minus equals to b. So this can also be written as a equals to a minus b. So if a's value is 8, then a minus equals to 6. So 8 minus 6, 2, and the new value of a will be 2. Next we have multiplication equals to. So this operator is a combination of multiplication and equals operator. This operator first multiplies the current value of the variable on the left to the value on the right, and then assigns the result to the variable on the left. So you have already done this assignment operators and also I'm just going a little bit quick in this as we already know all of this, right? So a multiplication equals to b can be also written as a equals to a into b. So if initially the value stored in a is 5, then a multiplication equals to 6 will set the value of a to 30. Then we have division equals to. So this operator is a combination of the division and equals to operator. So this operator first divides the current value of the variable on the left by the value on the right, and then assigns the result to the variable on the left. So we have a division equals to b can also be written as a equals to a divided by b. So if initially the value stored in a is 6, then a division equals to 2 will set the value of a to 3. So here are all of the examples also. If we have if we do a equals to 10, then and what this will do, this will set the value of a to 10, right? And it will print it. Then we are saying a plus equals to 10, so it will set the new value of a to 20, and that will be printed. Then we are saying a minus equals to 10, so from 20 10 will be subtracted and that will be printed, so we are getting 10. Then we have a multiplication equals to 10, so a's value is already 10, into 10 is 100, and that will be the new value of a. Then we are saying a division equals to 10, so 100 divided by 10, that is 10, right? And that will be saved in a. So we get value of a is first 10, then we added 10 to it, then we subtracted 10 from it, then we multiplied it by 10, and then we divided it by 10. Alright, so a very easy chapter. We have done all of these operators previously also. So now we are on the size of operator. So the size of operator is a unary compile time operator. So what this is, it's a unary operator. It's a unary operator and compile time. So basically this will be executed at the compile time, right? So when the code will be compiling, then this operator will be like executed, and it is used to determine the size of variables. So it's used to determine the size of variables, data types, and constants in bytes at compile time. So it can also determine the size of classes, structures, and unions, right? So this is what this will tell. This will just tell how much memory a certain variable or a data type will occupy. So number of bytes taken by different data types. So first size of over here can either get a data type and it can either tell that how much memory does a certain data type occupy. And the second use of it is size of expression, where you give it a variable or something, a number or something, right, and it will tell how much memory location it will occupy. So example 1 is number of bytes taken by different data types. So below is the C++ program to implement size of operator to determine the number of bytes taken by different data types. So over here we have number of bytes taken by char is size of char, right? So that is usually 1. Then we have size of integer, that is printed, that is 4. Size of float is usually 4, size of double is usually 8, and size of long is usually 8. So when we see number of bytes taken by char, that is giving us 1, by int is giving us 4, by float is giving us 4, by double is giving us 8, and by long is giving us 8. Note that these values, that the memory occupied by this like data types is platform dependent, meaning that may vary from a machine to machine, right? So or compiler to compiler. All right, so the next example is number of bytes taken by variables on different data types. So below is the C++ program to implement sizeof to determine the number of bytes taken by variables of different data types. So over here we have int a, float b, char g, right? So if we say size of a, that will give us 4, size of b, that will give us 4, and size of g, that will give us 1, right? So because a char variable will always occupy 1 byte, a float variable will always occupy 4 bytes, and an int variable will always occupy 4 bytes. Next, number of bytes taken by an expression. So below is the C++ program to implement sizeof to determine the number of bytes taken by an expression. So we have a equals to 5, long x is equals to 9, double p is equals to 10.2, and float g is equals to 2.5. So expression over here means, like if we say a plus g, right? So g is 2.5, a is 5. When we add them, and then we are taking the size of that, right? So when we say a plus g, what we have, we are getting a float value, and if we take out the size of a float value, what we get is it is occupying 4 bytes. Then we say a plus x. X is a long value, and that is occupying 8 bytes, and a is a int is occupying 4 bytes. So when we add those, it will tell us 8, that this will occupy 8 bytes, as we are adding a number of that is occupying 8 bytes and a number that is occupying 4 bytes, right? So the new if the 8 byte number is like over here it is 9, but for example if it was bigger than 4 bytes, right, then if for example it was exceeding the number of integer, right? So integer can occupy has a certain range of numbers it can save, right? So if long was saving a bigger number than that, then and we added integer value to it, then what would have happened? If we have said 4 bytes, then it would have been out of range, right? So a plus x is giving us 8 bytes, as we are adding a long number, so it will always give us the bigger numbers, right? Memory location. So long is a bigger data type than integer data type, so it will give us it will tell that a plus x is occupying 8 bytes, as long is occupying 8 bytes. Then we have a plus p, right? P is double and a is int, so double is occupying 8 bytes, so a plus p will also occupy 8 bytes. Next we have x plus p. So x is long, p is double, so that will occupy 8 bytes, as both of them are occupying 8 bytes, right? So when we add them, we'll get that x plus p is taking 8 bytes. Then we can also take out the size of the array using the sizeof method. So below is the C++ program to implement sizeof to determine the size of an array. So we have the main method over here. Then we have an x array, right, which has 1 2 3 4 1 2 3 5 6 5, 6, 7, 8, 9. So we have all of these numbers. Then we are saying length size of x, right? So over here what it will do, it will say every integer is occupying like 4 bytes, and there are 1 2 3 4 5 6 7 8, 8 of them. So 8 into 4, 32. So the memory is 32 bytes. 32 bytes are being occupied by this array, and then we divided by one of the elements, so that is size of one of the elements. So size of the element is 4. So when we say 32 divided by 4, we get 8, that is the length. And then we can print the length of the array is length, right? So that will be printed that the length of the array is 8. So over here we are taking out the length, we are not actually taking out the memory location occupied by the array, we are taking out the length of the array, and that is what we are getting, that is 8. If we have just taken out size of x and if we didn't divide it by x, one of its elements, the memory location occupied by one of its elements. So like if we would have divided by the size of one of its elements, right, then what would have happened, we would have gotten the size of array, like how much memory the array occupies. But right now we are getting the length of the array, that how many elements are there in this array. Next, we can also find the size of a class. So everything occupies memory, so we can also find the size of the class. So below is the C++ program to implement sizeof to find the size of the class. So we have class gfg, in which we have integer x only, right? Then we are creating an object of this gfg class, that is g, right? And when we take out size of g, right, that will give us 4. That is telling us that 4 bytes are occupied by this class. Then we can also take out size of pointers. So below is the C++ program to find the size of pointers, right? So over here we are creating a pointer variable a that is pointing to a new integer 10. So new integer 10 will occupy some memory location, right? And we are going to learn about the new keyword also very soon, right? So what is happening, basically right now we just saying that this new integer 10 will create an integer 10 that will be occupying some memory location, and we are saving that memory location address in a. Similarly we are doing with char, and similarly we are doing with double. Now what we saying, we are doing saying size of pointer a is, right? So we are first taking out the size of a, right? So size of a, basically we a, what is a giving us? A is giving us the value that is the memory location, so it will give us the memory address of your value, right? So address, how much that address is occupying, how much memory space that address is occupying, that is 8 bytes. When we dereference a over here, right, so when using star a, when we dereference it, right, then we are effectively checking the memory location occupied, the value that is stored in the memory location over here, right? So value that is stored in the memory location that is stored in a, right? So the memory location that is stored in a, its values size we are taking out, that is 4 bytes, as it is an integer. Then what we're doing, we're saying size of g, right? So size of g is 8, as g contains the memory address of a value, right? So that address size is 8 bytes, right? But if we say star g and we dereference it, so in there we'll get a like char value that is occupying 1 byte, so that will give us 1. And then when we say size of d, we are actually checking the basically how much memory location the address of the value 7.5 is occupying. So the address that we are saving is occupying 8 bytes, right? And when we say star d, we are checking how much memory location the value in that memory location is occupying, so that is also 8 bytes. So we concluded over here that the address that we are saving of any value or variable, that will give us 8 bytes, right? So its size will be 8 bytes, right? And the values size will be normal, right? So your value integer size was 4, char size was 1, and double size was 8. Now we have nesting of size of operator. So this is a new concept, very very cool concept. So what we have an x variable and we have the y variable. So now we are taking out the size of y, that is 4 bytes, and we are multiplying it by x. X is efficiently right now, what is x? X is 0, right? And then finally what we are doing, we are taking size of the whole thing, right? So logically we should be getting 4, but what we are getting 8. Why? Because what we have, y is a double variable, so it is 8 bytes, right? So we are multiplying an 8 byte number with a 4 byte number. So though we are getting 0, but that 0 is will be saved in 8 bytes. And when we take out the size of that 0, that will give us 8. So if you had one more example of this is, if you had double y is equals to 0. So as the value is 0, right? But it's a double variable, so a double variable will always occupy 8 bytes. Same thing was happening over here. We are multiplying this size of a double variable, right? So a double variable over here will give us 8, right? And though we are multiplying it by an integer and we are getting 0, but as it was a double variable that will occupy 8 bytes, the 0 that we are getting over here is will be occupying 8 bytes and will be of double type. So if we take out the size of that 0 in here, that is giving us 8. All right, so is this example clear?
Yeah, it's clear.
Alright, great. So next we have find the size of the structure. If we create a structure that we learned in the basic course also, then how to find the size of that. So over here is the program. So we are creating a structure GFG in which we have integer, we have float, and we have a char, right? And we are creating a basically instance of the structure g, right? So you remember how we created instance, we gave the variable over here, right? And it created an instance in this g variable. So now an instance of this structure is there in the g variable. Now when we check the size of this, what we'll get, we are getting 28. So this is not by adding all of these, like integer is like 4, float is 4, char is 1, that will give us 9, but we are getting 28, as there are many other things that are required in the memory, right? And the memory, we don't just have this integer, float and char, we also have many other things. So but over here, sorry, I just noticed over here, this is a char array, right? So this is a char array that will take 20 like 20 numbers. So over here the structure requires some external processes, right? So structure requires some things, right? So some memory it requires for itself also to create a structure, but over here it's not saving in the memory of the value of the structure. So value of the structure has z, d and s, right? So we have int z, that is 4 bytes, float d, that is 4 bytes, and then we have a char array, right? So I have missed this, right? We have a character array of 20 elements, so 20 into 1 is 20. So overall the value of the structure, right? So where we have z, d and s, that is 28. Though there are some other methods of the structure, some methods internally which it has to save, that will be saved in a different place, right? Over here right now what will happen, it is going to just sizeof will return us the like the memory location of the value. So this z, d and s is considered as a value of the structure, right? So kind of it's a like a value, right? So where we have z, d and s, that is kind of a value. So that's why basically I was saying, I thought that it basically saves in the same memory location the external internal things required for the structure to function, but there is actually a separate memory location for that, right? So as I did not see, this was a character array. Sorry for the point missed. And we will continue with the next example from tomorrow only, as the class is about to end. So thank you.
Thank you.